Graphing linear equations, the basic idea. In algebra, you will be working with equation. An equation is a statement that can be true or false. Here's an example of a simple equation in algebra. Now you can see this math problem contains an equal sign. That's what we call an equation. However, this equation is not true, neither false. Why? Because we're missing information. We're missing a number. That's the reason we have a box that is being added to 3, so we get 5. We're missing a number. So basically, we are being asked to find the missing number. So when we add 3, we get 5. From basic math, we know that number is 2 because 2 plus 3 equals 5. So we call 2 the solution of this equation because it made the equation a true statement. Now in algebra, we like to make pictures, visuals of our answers, of our solutions. So we're going to talk about the graph of an equation. And basically, because I'm only missing one number in this equation, our graph will be a horizontal line. And we're going to place or plot a point on the mark labeled as 2 to indicate that number is the solution of the equation. That's basically a graph of an equation. Now in algebra, we do not use geometrical shapes to indicate a missing number. Instead, we use variables, letters. Because I only have one missing number, that box, I'm going to replace it with the letter X. I only have one variable in this equation because I only have one missing number in the equation. We already know the solution of this equation is 2. Because 2 is going to replace the X. So when you add 3, you get 5. That's what we call the solution of the equation. Now, because 2 is replacing the X, when I look at the graph, that horizontal number line represents all the possible values that X could be. Now, because there's only one possible number that we add 3 to get 5, we put a dot on the 2. However, all of these numbers can be possible values of X. That's why this number line, this horizontal number line, we are calling it the X-axis because these are possible values of X. Only the number that contains the dot is the solution, the answer of the equation. Now, let's say I give you another equation about the same 3 numbers, 2, 3, and 5. I'm adding 2 numbers to get 5. However, instead of missing 2, let's say we're missing 3. So now the equation is going to look like this. Now this equation is different than the first one. Why? Because in the first equation, the first number in the addition was missing. In this second equation, the second number in the addition is missing. So that makes them look different. Now this equation, we are being asked to find a number. So when we add 2, we get 5. We already know it's 3 because 2 plus 3 equals 5. Now when I do my graph, I'm not going to draw a horizontal number line. Why not? Because that horizontal number line was for the possible values of X, the possible values of the box. Here in the second equation, I'm missing the second number in the addition of this equation. I'm missing the number for the 5-sided shape, the pentagon. So instead of drawing a horizontal number line, I'm going to be drawing a vertical number line. That's just to indicate that the solution, the graph that I'm going to make, the numbers for a different variable, for a different shape. So I drew the line vertical instead of horizontal because horizontal was for the box or the X. So now this vertical number line is for the 5-sided shape, the pentagon. So we're going to put a dot on 3. And the vertical number line are all possible values for the pentagon, but there's only one answer, one number, that when you add 2, you get 5. That was 3. That's why I put the dot there. Now, as I said before, instead of using geometrical shapes, we're going to use variables. Now, because the 5-sided shape is different than the box, they're two different shapes, the pentagon, we're going to use a different variable. Instead of x, x was for the box, the rectangular box. The pentagon, we're going to use a different variable. So I'm going to call it y. And we already know what is the value of y. So when you add 2, you get 5. We already know it's 3. So this vertical number line, because our possible values for y, we're going to call it the y-axis. Okay. The orientation of the line means that we are finding the solutions of different missing numbers. That's basically what I'm trying to convey here. Now, let's say I take the same equation, 2 plus 3 equals 5. Instead of missing the first number in the addition or the second number of the addition, let's say we're missing both numbers in the addition. Okay. Now here, this equation, I know it's an equation because I have an equal sign. It's missing 2 numbers instead of 1 number. Okay, so basically this equation, we are being asked to find 2 numbers that when you add, it will give you 5. Now, in algebra, we don't use geometrical shapes, so we're going to use variables. Because I have 2 missing numbers, I'm going to have, in this equation, 2 variables. The box will be x, the 5-sided shape, the pentagon will be y. And again, this equation is basically asking you, find 2 numbers, so when you add, the answer is 5. One possible pair of numbers that we can replace the x and the y, or we can fill in the rectangular box and the 5-sided shape, the pentagon, is 0 and 5, because 0 plus 5 is equal to 5. Now, I found a pair of answers. And when you have a pair of answers, we write it using a way or notation or a format of writing answers, and it's called order pair. We're going to write these 2 numbers in a parenthesis separated by a comma, where the first number is going to be for the x or the box, rectangular box, and the second number in the parentheses is for the y or for the pentagon. So the pair 0 plus 5 equals 5, the pair 0 and 5, look how we write it. That's one possible answer. So this equation doesn't have one numerical answer, it has 2 numerical answers. One value for the x and one value for the y. Now, when I try to make the graph, I cannot use one number line. I'm going to need 2 number lines. One number line for the x and one number line for the y. Now, I cannot put a point on the 0 because if I put a point on the 0, I need to decide that point is for the x or for the y. That's why 0, 5, when you put the point on 0, 5, you're going to put it up here. Why? Because that point is on the 0 on the x and 5 on the y. So that point, one single dot, is really a pair of solution. That point is 0, 5 because that's the pair that when you add, it gives you 5. Now, is that the only pair? No, there's more pairs. Another possibility is 1 and 4. 1 plus 4 equals 5. Now, you can see 1 is first, 4 is second. So when I write as a pair in the parentheses, it's called order pair. We write it like this, 1, 4. Now, what does that mean? That I'm going to put a point where the point line up with 1 on the x and 4 on the y. And that point is the pair 1, 4. Another possible pair that when you add is equal 5, 2, 3. So order matters, 2 first, 3 after. So 2, 3, the pair, when you add it up, is 5. When you put it in the graph, the point lines up with 2 on the x and 3 on the y. Another possible pair, it will be 3, 2. Careful, 2, 3 is not the same as 3, 2. Why? Because the numbers are different in each box. The first pair, 2, 3, 2 was in the rectangular box, 3 was in the pentagon. Now I had 3 in the rectangular box and 2 in the pentagon. That's different than 2, 3. So 3, 2 and 2, 3 are different points. However, that's a possible pair that when you add it up, it gives you 5. So we will write the pair as 3, 2. And look where will be the dot. The dot will line up with 3 on the x and 2 on the y. There's more pairs. Another pair is 4, 1. Very different than 1, 4. Order matters. So when I write it as a pair, as an order pair, it will be 4, 1. When I put it in the graph, the point will line up with 4 on the x and 1 on the y. Another possible pair is 5, 0. Which is very different than 0, 5 because the order of the numbers is different. So when I write as a pair, it will be 5, 0. When you put it in the graph, the dot will line up with 5 on the x and 0 on the y. And you can see that all of these points are neatly aligned on a straight line. However, there are more points. Another possible pair. I can use decimals if I want. 1.5 plus 3.5 is equal 5. That's a possible pair that will add up to 5. So the order pair will be 1.5, 3.5. And when I put the dot here on the graph, it will line up right there. And that point is lined up with 1.5 on the x and 3.5 on the y. And again, you can see that dot is neatly aligned with the other points, the other dots. I can use negative numbers too if I want. For example, negative 1 plus 6, that's equal 5. So that's another possible pair. So that pair, negative 1, 6, means that I'm going to place a dot on the graph here. So it lines up with negative 1 on the x and 6 on the y. And again, look at the points. It aligned, all of them are neatly aligned. And I can keep going on and on and on. And all the points that I keep finding, it will line up neatly on a straight line. So we can connect all of these points on a straight line. However, we do not need so many points to draw a straight line. What we really need only is 2 points. The moment you have 2 points, you have enough to draw a line. So instead of finding so many points to draw a straight line, the only thing you need is 2 points. Any 2 points that you can find, you can connect it with a straight line. In this case, I use 0, 5 and 1, 4. But I could have done it with any other 2 points. And that's the basic idea of graphing linear equations. I hope this helps.